In this video, we are going to see some basic geometric constructions, bisecting or dividing a line into equal parts. A line may be horizontal, vertical, or even inclined. Draw the line and mark its endpoints. For our reference, let the endpoints of the line are A and B. Now with the help of a compass, taking approximately more than half of the length of the line as radius, cut arcs on both the sides of the line from both the ends A and B. These arcs will intersect. Join these two intersection points of arcs by a straight line. This line is called the perpendicular bisector of the line AB. Perpendicular means these lines mutually makes 90 degrees. Bisecting means dividing equally. Dividing a line into many number of equal parts. Draw the line to the required size or the line to be divided into equal number of divisions. For our convenience, let the endpoints of the lines as A and B. Draw another line from the endpoint of the line AB. This line can be drawn with any acute angle. It will be good if the line is drawn with an angle between 15 degrees to 25 degrees. If the angle is more, the entire drawing may occupy more space in the drawing sheet. If the angle is very less, the drawing will be very congested. After drawing this acute angle line with any convenient distance, mark number of divisions on the line. This number is equal to the number of parts we need on the line AB. If you want the line AB to be divided into 10 parts, 10 divisions should be marked on the line. When the distance taken between the divisional points is more, it will occupy more space. Join this last divisional point of the inclined line with the other endpoint of line AB. Now parallel to this line, draw lines through all other points. Thus, line AB gets divided into equal number of parts. Bisecting or dividing an arc. An arc also can be bisected or divided into two in the similar way that of bisecting a line. Mark the endpoints of the arc. Take approximately more than half of the length in the compass. Cut arcs from both the ends of the main arc on both the sides. Join these intersection points of arcs with a line. Dividing an arc into equal number of segments. For dividing an arc into equal number of parts, the included angle of the arc is to be determined first. Join the endpoints of the arc to the center of it. Measure the included angle between these two chords. Divide this angle into number of divisions required on the arc. Mark this angle from one chord of the arc. Draw a line through this and extend it to meet the arc. Now measure this segmental distance of the arc by a compass. With this distance, cut further points on the arc to divide it into equal parts. Construction of polygons. Construction of triangle. A triangle is a three-sided polygon. There are many types of triangles. Equilateral triangle. An equilateral triangle has all the three sides equal in size. When all the sides are equal, all the included angles are also equal and is 60 degrees. Doesn't matter how big or small the side is, the angles are 60 degrees. Isosceles triangle. An isosceles triangle has two sides equal. When two sides are equal, its two angles are also equal. Scalene triangle. A scalene triangle has none of its sides equal. Similarly, none of its angles are equal. Acute angle triangle. An acute angle triangle has all its angles less than 90 degrees. Obtuse angle triangle. An obtuse angle triangle has one of its angle more than 90 degrees. Right angle triangle. A right angle triangle has one of its angle 90 degrees. Though there are many different types of triangles, in engineering applications, an equilateral triangle or regular triangle is more in use. While constructing an equilateral triangle, one side is drawn first with its size. Let the endpoints be A and B. This side can be in any orientation depending upon the application. That is, this side can be horizontal, vertical, or even inclined. Then in a compass, take the same distance as radius. From the endpoints A and B, cut arcs. Let these arcs intersect at point C. Join this point C with the endpoints of the line A and B. Thus, we get an equilateral triangle. Construction of a square. A square has four sides. A regular square has all the four sides equal and all the included angles between sides are 90 degrees. While constructing a square, one side of the square is drawn first with its size and the desired position. Let the endpoints of the first line or first side be A and B. Then from one endpoint of this side, draw a perpendicular line. A perpendicular line can be drawn with the help of a protractor by taking 90 degrees from the endpoint of the line. Measure the distance of the side in the compass and mark it on this perpendicular drawn from the endpoint and name it as C. This line BC is the second side of the square. Again with the same radius, cut arcs from both A and C. This intersection of arcs is D. Join C and D, which is the third side of the square, and join A and D also. This is the fourth side of the square. Construction of a pentagon. A pentagon has 5 sides and a regular pentagon has all the 5 sides equal and angle between the sides 108 degrees. There are several methods to construct a pentagon. Let us discuss the simplest one. Draw one side of the pentagon AB with its size and in the required position. Since the included angle is 108 degrees, the external angle of the pentagon is 72 degrees. Draw a 72 degree line from endpoints A and B. Measure the size of the side in the compass and mark it on the lines drawn from A and B. The point marked on the line drawn from B is C and the point marked on the line drawn from A is E. Again with the same radius, cut arcs from both C and E. These arcs intersect at D. Join C and D and E. Thus the pentagon is constructed. Construction of hexagon. Hexagon is a six-sided polygon. The included angle between sides of hexagon is 120 degrees. For constructing a hexagon with two sides horizontal, draw a horizontal axis. In the compass, measure the side of the hexagon. Draw a circle by keeping the pin point of the compass approximately on the midpoint of the axis. Again with the same radius, for the intersection points of the circle and axis, cut arcs on the circle on both the sides of the axis. These intersection points on the circle can be joined with straight lines. Thus we get a hexagon with two sides horizontal. If you want the hexagon to be drawn with two sides vertical, the same procedure can be followed, but by starting with the vertical axis. To have a hexagon with sides at a specific angle, initially draw one side with the given angle. Take the size of the side in the compass and cut arcs to intersect. Now this intersection point as center, draw a circle. You may notice that the circle will be passing through the end points of the first side. We have measurement of side of the hexagon in the compass. From the end points of the first side, cut arcs on the circle. Again from these intersection points, cut further arcs on the circle. Join all these points on the circle with straight lines. This is our hexagon with two sides certain degrees inclined, tangent to a circle from the given point. Draw the circle and mark the desired point P from which the tangent is to be drawn. Draw a line connecting this point P and the center of the circle O. Draw a perpendicular bisector for this line. This is drawn to find out the midpoint of the line OP. Let the midpoint of line be M, with M as center and MP or MO as radius. Draw a circle to intersect the previous circle. Let these points be T1 and T2. Join point P with T1 and T2. These are the tangential lines to the circle. External tangents to two circles. Draw the circles with a given radius. Let the center points of the circles be P and Q. Join P and Q with a straight line. Now draw a circle from P with radius equal to the difference in radius of other two circles. Draw a perpendicular bisector for the line PQ. Draw a semicircle from the midpoint M of the line PQ with radius MP or MQ. This semicircle intersects the circle which is drawn just before. Join this point to the center of the circle and extend it to meet the larger circle at X. Parallel to this line, draw another line through the center Q of the next circle. This line meets the smaller circle at Y. Join X and Y. This line XY is the tangent for the two circles. Internal tangents to two circles. Draw the circles with the given radius. Let the center points of the circles be P and Q. Join P and Q with a straight line. Draw a third circle with a radius equal to the sum of the radius of other two circles. Draw a perpendicular bisector for the line PQ. Draw a circle from the midpoint M of the line PQ with radius MP or MQ. This circle intersects the circle we have drawn just before. Join that point with the center of the circle. Mark the point on the smaller circle as X. Parallel to this line, draw another line from the center of the next circle. This line meets the circle at Y. Join X and Y. This line XY is the tangent. Tangential arc between two lines when the lines are perpendicular. Draw the lines which are mutually perpendicular. In a compass, take the radius of the tangential arc to be drawn. From the intersection point of these lines, cut arcs on the lines. From these intersection points, draw arcs. With the intersection point of these arcs as center, draw the desired tangential arc. Tangential arc between two lines when the lines are making an acute angle. Draw the lines with the desired angle between them. Draw perpendicular to both these lines. On these perpendiculars, mark the radius of arcs to be drawn. Through these points, draw parallel lines to the baselines. These parallel lines will intersect. This intersection point is the center of the tangential circle. Now draw the circle. Tangential circle between two other circles. Let the radius of the circles be R1 and R2. R3 is the radius of the circle to be drawn tangentially to the other two circles. First, draw the circles with R1 and R2 as radius. From the center of the R1 circle, draw another circle with radius equal to R1 plus R3. From the center of R2 circle, draw another circle with radius equal to R2 plus R3. Intersection points of these two circles is the center of the tangential circle. Draw a line connecting this intersection point and the center of circles. Those lines will intersect on the corresponding circles. These are the tangential points of the circles. Now draw the circles with R3 as radius.